In this video, we explore another case of logarithmic differentiation. We know from previous discussions that the derivative of x raised to some constant n is nx raised to the power of n minus 1. We call this the power rule. And we also know from previous discussion that the derivative of a to the x is a to the x times ln of a, where a is a positive constant. So how do we evaluate the derivative of functions like x to the x? Well, we can't use the power rule since x is not a constant, and when we apply the definition of the derivative, we end up with not the same result, and we can't apply the second rule straight up since x is, again, not a constant. So what do? Well, we start by rewriting the function as e to the ln of x to the x, where the exponential and logarithmic operators undo one another, and then we apply the rule of logs to bring down this exponent, and then we rewrite the expression as the derivative of e raised to the quantity of x times ln of x. And we see that we have a composite function where we have e raised to the power of some inner function. So when we apply the chain rule, we have the derivative of the outer function, which in this case is e raised to the quantity of x times ln of x, times the derivative of the inner function, which is the derivative of x times ln of x, to which we apply to this inner derivative the product rule. And so we have the derivative of the first term times just the second term plus just the first term times the derivative of the second term, and in this case it's 1 times ln of x plus x times 1 over x, and or we can more simply as just ln of x plus 1, and then finally we rewrite e raised to the quantity of ln of x to the x in its simple form, x raised to the power of x, and we have our final result, which is x to the x times the quantity of ln of x plus 1. And we can apply this formula when we have the form some base raised to some exponent, where both the base and the exponent depend on x. And this concludes this segment.